Hello everyone, I'm Xinquan Jiu from the Chinese Academy of Science. Today I will present our work, Revisiting Visual Corruptions in LVLMs, a shift texture perspective on model failures. In this work, we study why large vision language models fail under corrupted visual inputs and how we can improve their robustness without additional training. Large vision language models have shown strong visual understanding abilities, but they are still highly vulnerable to corrupted visual inputs, such as noise, blur, color shifts, and geometric distortions. This raises two natural questions. First, why do LVLMs fail under heterogeneous visual corruptions? Second, can they improve their robustness without retraining the model? Our core idea is that visual corruptions should not be treated as uniform noise. Instead, they are heterogeneous perturbations that affect LVLM perception along two complementary dimensions, shape and texture. Based on this view, we identify two distinct failure modes, shape-degraded failures and texture-degraded failures. Finally, we propose shape-texture dual-pass contrastive decoding, or STCD, a training-free framework that uses complementary contrastive views to expose and correct these failure modes. Our key observation is that different corruptions lead to different types of failure of model failures. For shape-degraded corruptions, such as blur or geometric distortion, the global structure and object contours are damaged. In this case, the model turns to rely more on local texture cues and may predict texture similar but shape mismatched categories. For texture-degraded corruptions, such as noise and color shifts, the local appearance and texture information are disrupted. The model then relies more heavily on global shape cues and may predict shape-similar but texture-mismatched categories. So the important takeaway is that corruption-induced failures are not random, they are structured. This motivates us to understand visual corruptions through a shift texture perspective and to design a method that can handle both types of failures. To address these two failure modes, we propose shift-texture dual-pass contrastive decoding. The main idea is simple. Given a corrupted image, STCD constructs two complementary contrastive views. The first one is the shift pass. We use an edge-extracted view to emphasize global contours and object structure. This pass helps diagnose errors related to unreliable shape information. The second one is the texture pass. We use a jigsaw permutated view which preserves local texture statistics but disrupts global spatial structure. This path helps diagnose errors related to unreliable texture information. Then STCD compares the model's logics from the original corrupted image, and from these two contrastive views, the differences provide shape-specific and texture-specific correction signals. Finally, these two corrections are adaptively fused through using entropy-based weighting. In other words, when one contrastive path is more confident and reliable, STCD gives it a stronger influence. The resulting framework is training-free, corruption agnostic, interpretable, and effective for heterogeneous visual corruptions. We evaluate STCD on three representative LVLMs and four robustness benchmarks. These benchmarks cover both synthetic corruptions and real-world image degradations. The main result is that STCD consistently improves robustness across different models, data size, and corruption types. It also outperforms standard visual contrast decoding while maintaining only modest inference overhead. These results show that explicitly modeling shipment texture-related failures provides a practical way to improve LVLM robustness. To conclude, this work makes three main points. First, we propose a heterogeneity-aware view of visual corruptions. Instead of treating corruptions as simply the opposite of clean data, we show that they can be understood along two nearly orthogonal perceptual dimensions, shape and texture. Second, through qualitative and quantitative analysis, we show that different corruptions induce two characteristic failure modes: shape-degraded failures and texture-degraded failures. Third, motivated by these findings, we propose STCD, a simple training-free contrastive decoding framework across multiple models and benchmarks. STCD consistently improves robustness compared with existing methods. Overall, our work suggests that leveraging the complementary between shape and texture is an effective principle for building more robust multimodal models.